Number 1, on rational expressions and equations. Well, number 1 is just talking about excluded values. Yeah, when you get a rational expression, talking a polynomial fraction basically, you run into these excluded values. What do I mean? What do I mean by that? The excluded value is a value that makes the denominator 0. Yeah, we have to exclude any value that makes the denominator 0. So if I had, number 2, x minus 3 over 6x minus 21, what would be my excluded values there? Well, I don't want the denominator to be 0, so my denominator here is 6x minus 21, so if that equals 0, yeah, I'm going to exclude that. So just solve that. Add 21. 6x equals 21, divide by 6, and that reduces by 3 to 7 halves. That would be excluded, 7 halves. Now, yeah, what about the 3? 3 would make the top be 0. Is the top equals 0 bad? Top equals 0 is not bad. It's okay to have the top be 0. So 3 would be okay. X is 3 would make the top 0. The bottom, though, would not be 0, so that would be okay. It's just that the bottom, if it's 7 halves, that denominator is going to be 0, and that's what you don't want. So 7 halves is the one and only excluded value. All right? Now, looking at number 3, write or simplify to lowest terms x squared minus 6x minus 27 over x squared minus 15x plus 54. All right. Little rule of thumb on simplifying or writing in lowest terms fractions like this. If you see something to factor, you better factor it, okay? Really, it amounts to you can only cancel factors, however you want to think of it. But yeah, when you're simplifying these, if you've got something that factors, factor first. Little warning on that, okay? Factor first. So I can factor my numerator, x squared minus 6x minus 27, do a little trinomial factoring there. 2 binomials, x and x. Minus 27, 9 and 3. With minus 6, so that's going to be a minus and a plus. X squared minus 15x plus 54, it factors x and x. Got 54 is 9 and 6. And with the minus 15, if both of those are minus, it works. With me on that so far. So factor first, then do the canceling. And remember, only cancel factors that are exactly alike. X minus 9 works. You can cancel it, but what about the x plus 3 over x minus 6? That's not an exact match, so I can't cancel there. That's it. Binomials have to exactly match to cancel. All right. Number 4, well, same sort of deal. 15x squared, x minus 4 over 9x, 4 minus x. Okay? Yeah, we'll work on this a little bit. Can't cancel them as they are. 4 minus x is not exact match with x minus 4, but we'll work on that. Now, on these others, these monomials, we're not talking binomials. Yeah, just look at those individually. Those reduced by 3. So that gives me a 5 there and a 3 there. Then that's subtracting exponents, isn't it? So that gives me an x to the 1 right there. Now, about this, remember what we did on that is, yeah, you can make this an exact match by pulling out a negative 1 here. Pull out a negative 1, that makes it a minus 4 plus x, but minus 4 plus x is x minus 4, isn't it? Yeah, that gives me an exact match that I can cancel out. So I have 5x over 3 times negative 1 be negative 3, or some version thereof. Yes?
So go back to number 3.
Back to number 3, okay.
On the bottom, I got a negative 18 and 3, and it worked.
Okay. Negative 18. Well, the thing on that, if you try that, is, yeah, it's negative 15, all right, but what's this times that? It's a negative 54, isn't it? You need a positive 54. So you got to have both of them be negative, you see. Yeah. Yeah, you got to watch both signs. Okay. We're okay on that then? Number 4, is that okay? All right. Right along here, number 5. Got another equation to solve here. Looks like a long one. Well, again, on these rational expressions, you've got something you can factor. That's probably a good idea to factor it, and just so happens that denominator there does factor. So I'm going to factor that out first. Which will leave me 2 binomials, x and x, 3 and 1, positive 3 and negative 1. Okay, all right, so with this type of equation, in this format here, it's an LCD, isn't it? Use an LCD. Get your LCD, which is just need a representative of each kind. Binomial there. Got an x minus 1 binomial, an x plus 3 binomial, so that's going to be my LCD. Multiply it by all parts. X minus 1, x plus 3, 5 over x minus 1. X minus 1, x plus 3 times that one. And then x minus 1, x plus 3 times that one. And nice things do happen, cancellation-wise. The x minus 1's cancel here, so I'll wind up with 5 times x plus 3. Here the x plus 3's cancel, so I'll wind up with 6 times x minus 1. And then here both binomials cancel, so that just leaves me a 7 there on the right. And yeah, this is multiplied by 5, so both of those, so it would be 5x plus 15. Both of those multiplied by 6, so that would be 6x minus 6 equals 7. 5x and 5x is 11x. 15 minus 6 is 9, positive. That equals 7. Subtract 9. So I get 11x equals negative 2. And all I have to do then is divide by 11. Negative 2 11ths. Looks like an answer. Now, be sure it's not an excluded value, because, yeah, you can run into excluded values since we have denominators with variables. And it looks like 1 would be excluded, negative 3 would be excluded. Not so much negative 2 11ths. It's okay. With me on that? Last page here. Number 6. Got a similar one to number 5. 3 over y minus 7 over 2y minus 8 equals 9 over 8y. Well, there's a denominator that's factorable, so I'm going to factor it first. Got a common factor of 2 in that one, so I'm going to pull out a 2, so make it 2 times y minus 4. Rest stays as is. So what LCD now do we have there? Well, I need a y minus 4. Then I've also got some factors of y here, don't I? So I need a y. And then I've got 2 and 8, so what do I need for those? Least common multiple of those. I need a multiple of both of those. 8 would be a multiple of those, wouldn't they? Both. So 8y, y minus 4, is going to be my LCD to multiply by all places. 8y, y minus 4, times 3 over y, minus 8y, y minus 4, times 7 over 2, y minus 4. And then 8y, y minus 4, times 9 over my 8y. What cancels? Well, up here in front, the y's cancel. All right, so that leaves me an 8 times y minus 4 times 3. Let's just write it that way. Here, y minus 4's cancel. 2 also cancels out because it goes into 8 4 times. So I have 4y times 7, so I have a minus 28y there. And then the last one, the 8y and the 8y cancel. So I have 9 times y minus 4 on the end on the right. See if you got me on that. Okay, well, here's the thing. I've got two numbers to multiply here, so 8, that'd be 8y minus 32, but times the 8. But then I got to multiply it by 3 as well, so what do I get there? It'd be 24y minus 96, because I have to multiply both by 8 and by 3 there. So I get 24y minus 96 for that one. Minus 28y. Then over here, times 9 would be 9y minus 36. So finally here, to an equation to solve, be minus 4y, 24 minus 28, minus 4y minus 96. It's 9y minus 36, so I'm going to subtract my 9y, add 96. And here's what I'm going to get. For that there, I'm going to get negative 13y. And those are out, 60. Equals 60. I do believe. Check me on that. Did I get that looking right? Okay. All then I have to do is divide by negative 13. Y equals negative 60 over 13. It's not an excluded value. There we go.
I get everything of that except what you did with the 2y minus 8.
Okay, 2y minus 8. Oh, right here. I just factor. Yeah, the 2y minus 8 has a common factor of 2. So, yeah, anytime you have denominator factorable, that'll be your first step. Factor it out. Any other questions about any step? That was a doozy. I'll give you that one. All right, number 7. 2 more here. Number 7. We have 4 over x minus 3 equals negative 2 over x plus 7. yeah, this brings up the point that to solve this one, we can do what? Yeah, if you have one fraction equals another fraction, just one fraction each side, you can use a little thing we call cross multiply. Just like it sounds, multiply across. We got top here times bottom over there, so it's 4 times x plus 7. Then the top over here, negative 2, times the bottom over here would be x minus 3. And those two things, cross products, equal. All right, so that would be distribute 4x plus 28, right? Then distribute here, negative 2 times x is negative 2x. Negative 2 times negative 3 plus 6 plus 6. It's a little bit easier than that last one. All right, now just add the 2x, both sides. Subtract the 28, also both sides. That'll be 6x. That'll be negative 22, I believe. Divide by 6, and we'll have x equals, that reduces by 2, so that'll be 11 thirds, negative 11 thirds. Okay, let's see. Go with number 8. 1 over f equals 1 over p plus 1 over q. And what I've got, f is 7, q is 10. What's p in that case there? Well, plug those in. 7 for f, 10 for q. We get this. 1 over 7 equals 1 over p plus 1 over 10. That is really something similar to one of the ones we've been working here. Yeah, it's just a fractional equation, and this one, how are we going to do it? An LCD? Get an LCD on that? Yeah, for the 7 and the 10, we got 70, and we need also a factor of p. In my LCD, need a factor that goes for all those. 70p is my LCD. Multiply that then by all three of those. 70p times 1 over 7. 70p times 1 over p. And 70p, whoops, times 1 over 10. Do a little canceling out. Since that's 70 over 1, I can cancel the 7 factor there. So that gives me 10 left. 10p times 1 is 10p. What happens here? P's cancel. That's just 70. Plus here, 70 over 1. So cancel by 10s. 7. 7p times 1 is 7p. Yep. Nice equation. Just solve for p. Subtract 7p. 3p here equals 70. Divide by 3. P equals 70 divided by 3. How about that? All right. So a little bit of some of the stuff we did.